Righto, so I've made my way back to the menu. Now what I'm going to do in this is I'm going to go to the statistics screen. And this time I'm going to go calc and I'm going to have a look at distributions. This is a fairly special part of the statistics screen. I really like it. So it really helps us to visualize what's going on. I'm just going to look at binomial PDF. So X, that's the number of outcomes. It doesn't really matter for this. Like, I'm not going to try and calculate anything. I'll just use 3. And the number of trials can be 5. And the possibility that we had in the last question was 0.32. So when I do that, it tells me that the probability of X equaling 3 is this number here, which I'm probably going to need in this next part of the question. But there's a really cool thing that we can do up here, which is just hit the graph button. And it shows this. So this is the graph of the binomial distribution. And we can see the probability of X equaling 0 here, the probability of X equaling 1 up here. So X equaling 1 is the most likely outcome. Okay, it's most likely that this archer will get just a single bullseye. It's also quite likely that they would get 2 bullseyes, but less likely that they would get 3, and less likely again that they'd get 4, and almost 0 is the chance of getting 5. I'm just hitting across on the screen there, so we can actually see the different probabilities popping up down the bottom right hand corner. And yeah, that's just a really nice feature. We can also see that this graph is positively skewed, so it goes up quickly and then it gradually comes down to the endpoint. So this is generally going to happen when the probability of your binomial distribution is less than 0.5. If it's equal to 0.5, you'd get a symmetrical distribution, and if it's equal to something greater than 0.5, then you'd get a negative skew. So let's just have a quick look at that. I'm just going to make that possibility 0.68. I'll turn it around. And I'll graph it. So there we have it. You can see I've made the probability greater than 0.5, and it's got a negative skew to it. It's running down that left-hand side there. And I'll just change it again to make it 0.5, just for curiosity's sake. And there's the graph, so you can see it's a nice symmetrical distribution. Okay, so just, yeah, it's a really interesting feature of the calculator, and it is another way that you can find out what those probabilities are. Now, what I'm going to do is I'm going to jump back here. I'm just going to fix up the probability again as 0.32. And it was 1515. So, to do the last question, part B, this is going to let me actually do it. Oh, made a bit of a mess here. Righto. So, in part B, we're looking for the probability that X equals 3 given X is greater than or equal to 1. So, that's equal to the probability of X equaling 3 intersection X greater than or equal to 1 divided by the probability that X is greater than or equal to 1, just given from the conditional probability rule. Now, where X is equal to 3 and X is greater than or equal to 1, let's just have a quick look at that on a number line. So here's 1, 2, 3. When X is greater than or equal to 1, that's all of this part along here. When X is equal to 3, that's this part here. So the part where these are overlapping is just there where X is equal to 3. So this numerator I can actually just write as the probability that X equals 3 divided by probability that X is greater than or equal to 1. And so, subbing in the values that I know there, I found that that first one was 0.1515, and that's divided by the probability from the last part, which is 0.8546, and then you just type that into the calculator. And when you type it in, I've just done it here, so you can see it's equal to 0.177. I'm only going to write it with 3 decimal places of accuracy, just because I did round off the answers here, and there's a potential for it to have messed it up a bit. So I'm just going to make sure that I keep that additional level of accuracy there by just keeping it to 3 decimal places, which is 1 less than the number of decimal places I had here. Anyway, didn't specify for anything in the question, so that'll be it. And that is exercise 14A done. See you guys.